Hi there, back again with lesson 6.3b. We are going to be solving a linear system by elimination. Now, if you were in class for 6.3a or you watched the 6.3a video, you learned how to solve a system by elimination. It's where we add the equations together to get one of the variables to eliminate. But sometimes we do have to change one of the equations, or both, by multiplying by something. So let's take a look at example number 1. I want you to look at the x values and the y values, and you notice that if we try and add them, nothing will cancel out. So what could we multiply one of the equations by to get either the x or the y to cancel out? Do you see how the y is 6 here and it's 3 here? Could we turn the 3 into a 6 by multiplying by 2? We could. However, we need to get them to cancel, and they can't be both a positive 6y. This one, we'd have to make a negative 6y. So to get 3y to be negative 6, I'd have to multiply the entire bottom equation by negative 2. I'm going to write that right here to remind me. Okay, so if I multiply this by negative 2, remember everything by negative 2. That's what I would have. Now the top equation is going to stay the same. Now do you notice how if we add the equations, the y will cancel out? Let's do it. 9 minus 16, negative 7, cancels out, makes 0. And then we have 12 minus 26, x equals 2. So in our solution box, we know that the x-coordinate is positive 2. Now, in order to get the y-coordinate, I'm going to have to plug in x equals 2 into either one of the equations, whichever one do you think is easiest. Now, I'm just going to pick the bottom equation because I have some workspace right here. So I'm going to do x equals 2 right in the bottom equation. So right here for x, I'm going to make it a 2. And now what I'm doing is solving for y. I'm going to find the y-coordinate. I think I've got it. Does your answer match mine? Y is negative 1. And there you have it. We found the solution. Those two lines are going to intersect or cross on a coordinate plane at the point 2, negative 1. Great. Let's take a look at number 2. Again, looking at both equations, I want to see, could I turn a 14 and a 4 into something? Is there a multiple I could turn those two in? What about a 6 and a 21? I think if I double 14, it would be 28. And I know that if I take 4 and multiply it by 7, I get 28. So maybe I could do that. Well, that would mean one of them, though, is going to have to be negative to get them to cancel out. So let's make the top one negative. Remember, I want that 4 to be a negative 28. So I'd have to multiply it by negative 7. The bottom one, let's get that to be positive 28. So I'm just going to double it. Now let's just copy the equations over here in our workspace. So everything on the top equation is just going to be multiplied by negative 7. That negative 28. Negative 7 and negative 6 plus 42. Negative 7 times 5. Now the bottom equation, we're doubling everything. 2, negative 21, negative 42y, and 2 and 15 make 30. Okay, now we are ready to add them together. Okay. Now remember, we were trying to get the 28 and a negative 28, so the x's could cancel out. And they do, they make 0. Oh boy, a positive 42 and a negative 42y, that also makes 0. So the value of the entire left side is 0. The variables canceled out. On this side, negative 35 and 30 makes negative 5. And I have 0 equals negative 5. Well, I know that that is not true. My variable canceled out, and I get a not true statement. What do you think that means? You're right. It does mean no solution. Not true, no solution. Our variable canceled out. Well, what that means is that our two lines, if we were to graph them on a coordinate plane, they're going to be parallel. They're never going to intersect. Not bad. Pretty cool. Okay, well, that's what that looks like with the elimination method, a no solution. Let's try number 3. Okay, looking at both equations, again, if I add them together, nothing's going to cancel out. Is there a number you could change 6 and 9 into? Is there a multiple of 4 and 6 that we could change them both into? How about 4 and 6? Could I make a 4 a 12 and a 6 a negative 12? Yes. Remember, one of them has to be positive, one of them has to be negative. So let's do it. Let's take the top and let's make this 4y into a 12y. In order to do that, I'd have to triple this equation. 3 times 4 is 12. Now to make this 6y a negative 12y, I'd have to double it, right? But make it negative. So times it by negative 2. Let's try this. Let's rewrite these equations. I'm going to triple the top one and multiply the bottom one by negative 2. Our goal is to get this to be a positive 12y, and this will be a negative 12y, and they'll cancel. Let's do it. Triple everything. Three times 16 is 48. I'll get my handy little calculator right here. Negative 2 times 9x, negative 2 times 6y, and negative 2 times 24. Great. Add them together. Oh, 18x minus 18x, that's 0. 12y, negative 12y, that's 0. The value of the entire left side is 0. Oh boy. 48 and a negative 48, that's also 0. I end up with the variables canceling out and 0 equals 0. That's true. That's an identity. What do you think this means? You're right. It means infinite. Can't spell today. Infinite solutions. So what that means is that if I were to take both of these equations and graph them on a coordinate plane, I'd have one equation with the other one right on top of it. They would be coinciding. They're actually the same line. If you were to rewrite both of the equations, they would both be exactly the same line. Wow, that's kind of cool. Let's look at number 4. Okay, again, let's take a look at the equations. Right now, if I add them, nothing will cancel. You know, a 3 and a 2, you can make it 6 and negative 6. But wait, look here. A negative 4y, I can make this a positive 4y right here by just multiplying the bottom by 4. Let's do that. The top equation stays the same. The bottom equation, we're going to quadruple it. 8x plus 4y, negative 28. Now let's add them together. Let's see what happens. 3x and 8x makes 11x. Yep, just what we wanted. The 4 and the negative 4 cancel out. Bring down your equal sign. Now I have a negative 27 and a negative 28. That's negative 55. X equals negative 5. Looks like we're going to get a solution on this one. I have an x coordinate, so now I need to find the y. Now remember, to find the y coordinate, you have to plug in x into either one of the equations. I'm just going to use the one that's right here at the bottom because I have some workspace. So 2x, remember x is negative 5, plus y negative 7 and 10 make 3. I found my y coordinate. So right over here, I'm going to put y, and there we have our point. That's where the lines are going to cross. And you can hear my puppies barking. Oh, puppies. All right, we got them done barking, I hope. Okay, number 5. Let's look at 5. Okay, get ready to add the equations together. Nothing's going to cancel here, so I'm going to have to change them. 18 and 4, 9 and 2. Do you see with the 9 and 2, I could change them both into an 18, couldn't I? If I double the 9, I make it 18. And then if I make this negative 18, I can just multiply it by negative 9. Let's do it. Let's double the top because that will be 18. And then the bottom, we'll multiply by negative 9 because then it will be negative 18. Let's get ready to rewrite these. Doubling everything across the top. 2 and 18 make 36. And a 2 and a 48. Now everything across the bottom has to get multiplied by negative 9. So negative 18x, negative 9 and 4, negative 9 and 12. Perfect. Well, looks like we got our 18 and our negative 18 like we wanted. Cancel. Makes 0. But wait, 36 and negative 36, oh, that cancels too. And I get 0 as a value on the left side. Now over here, I have 96 take away 108. Or remember, we're adding, so 96 plus negative 108, which is the same thing. That's negative 12. Well, my variables canceled out, and I ended up with something that is not true. So not true means no solution. So if I were to rewrite these equations, y equals mx plus b, I would end up with a set of parallel lines. There's no solution, so they're never going to cross. Great, we got that one. Number 6. Take a look at both equations, see what you can do. A 2 and a 6? Well, I could make the 2 into a negative 6 easily by multiplying by negative 3. A 4 and a 2, you could make this into a negative 4 easily also. Your choice. Let's go with the 2 and 6. So here I have a positive 6. I'm going to make this a negative 6. And all I would have to do is multiply by negative 3. So let's rewrite this equation, multiplying everything by negative 3, and then you're not going to change the bottom one. Negative 3 times 2. Negative 3 times 4y. And negative 3 times 11. Then keep the bottom one the same. Let's add them together. Well, looks like what I wanted to happen did. I got a negative 6x and a positive 6x. Cancel. Oh, okay. Looks great. Perfect. We can add these together. They're not going to cancel. For a minute, I thought they were. Negative 12 plus 2, negative 10y. Negative 33 plus 3, negative 30. Solution. I have a y coordinate. There it is. Plug it in right away. Now that I know that y is equal to 3, I have to go back into either equation and plug in y is 3. I'm going to go to the bottom one since I have some workspace here. So y is 3. 6x plus 2, y is 3. So I just substituted the 3 there. Now I have to solve for x. Three minus 6, negative 3. Negative 3/6. 3/6, or 3 out of 6. That's a half. And now I have my x value. It's negative 1/2. So these two lines are going to cross at the point negative 1/2, 3. Very good. We got a solution for that one. Let's see what happens in this one. We're either going to get a solution, 1 point, or we're going to get no solutions or infinite. Let's see what happens. Take a look. 5 and a 2. They won't cancel. I have to change. Can't cancel. Okay, so I'm going to have to multiply something. I have a 15 and a 6. Well, 30 comes to mind. I can make this a 30 by doubling it, make this a 30 by 5. But you see 5 and 2? Yeah, that looks easier. I can make them both into a 10. Let's do that. So if I double this equation here, I'm going to make this is going to be a positive 10. To make this now a negative 10 so they can cancel, I'd have to multiply by negative 5. Now this will be a positive 10x and this will be a negative 10x. Let's rewrite the equations. Remember, everything's doubling on top. Now the bottom one, everything's being multiplied by -5. -5, -6, +30. -5, 10. And we are ready to add them together. Looks like the x's are going to make 0. They cancel. Ooh, the y's make 0. They cancel. Value of 0. 50 and a -50. They cancel. Value of 0. The variable canceled out, and I am left with an identity, a true statement. 0 equals 0. Remember, that means infinite solutions. Done. Same line, one line on top of the other, coinciding. If you rewrote those, both y equals mx plus b, they're going to be the same line, infinitely many solutions. And now we are on our last one. So looking at both equations, I can't just add them together and have anything cancel out. So what are you going to do here? Nothing really comes to mind with a 33 and a 6. But here, 11 and a 2. If I think of the multiples of 11 and a 2, 22 comes to mind. I can make this a 22, a -22. I just have to double it. And I can make this a 22 by multiplying by 11. Let's do it. If I double the top, 2 times -11 is -22. And if I multiply the bottom by 11, 11 and 2 make +22. I think this will work. So double everything in the top. Doubled. Everything in the bottom we're multiplying by 11. We got 11 and -10. Add them together. Let's see what happens. 66 and a -66 cancel. There we go, -22 and a +22 cancel. Value of 0. Now I have -80 and -110. -80 plus -110 is -190. It looks like we end up with the variable canceling out and a statement that is not true. Not true means no solution. And we know that that is a set of parallel lines that will never intersect. No solution. Very good. Let's go down to the summary. Now, sometimes when we have a linear system, we're going to see that the lines are going to cross or intersect at one point where we get one solution. But in some cases, oh, there they go again, barking. But sometimes we're going to get a linear system that has no solution or infinitely many solutions. So if I end up with the variables canceling out completely when I'm using the elimination method, and I end up with something that is not true, like for instance this one, 0 equals -90, I know that my answer is going to be no solution. Not true, no solution. But if I end up with the variables canceling out, and I end up with an identity. Remember, identity is identical on both sides. That means infinite solutions. And that would be something like this right here. If I slide this up, remember the variable canceled out. We got 0 equals 0, and that was an identity, infinitely many solutions. So if the variable cancels out, you're going to have no solution or infinite solutions. But if the variables don't cancel out, then you're going to have a solution. You're going to have to solve for x and y. And there you have it, lesson 6, 3b. Have a great day.